You are welcome to yet another session. This is the last session under Unit 2, the orientation of electrophilic substitution reaction in naphthalene derivatives. So at the end of the session, you should be able to identify the position on the substituted naphthalene that a second substituent will attach itself. You should be able to identify an already substituent on the naphthalene nucleus as either activating or deactivating group. And also, lastly, you should be able to prepare a di or tri-substituted naphthalene. So first of all, before we begin, we will look at what can guide us into directing an incoming substituent to either the first ring of naphthalene or the second ring of naphthalene, or even on that same ring, which carbon number position would the incoming substituent go to, with respect to the fact that there already is an existing substituent already on the naphthalene ring. So first of all, we look at some of these substituents are regarded as activating groups and some are regarded as deactivating groups. So we first of all take activating groups for now. An activating group, which is also an electron donating group, tends to direct further substituents into the same ring. So what it means is when there's an activating group already on the naphthalene ring, it tends to direct all other incoming groups to the same part of the ring. So if there's an activating group on this side of the ring, any incoming group is directed to the same part of the ring and not the second ring. So an activating group in position 1 or alpha position will direct further substitution to position 4 and to position 2, right? So if it directs the incoming substituents to position 4, then that is the major product, and if it directs it to position 2, that becomes the minor product. Now again, if there's an activating group at position 2 and there's an incoming substituent, that substituent is directed to position number 1. Okay, so these are typical examples of deactivating groups. OH, OR, alkyl, amine groups, etc. are activating groups, and these activating groups, when present on the naphthalene ring, directs incoming substituent to other positions. So if the activating group is at carbon number 1, it directs all incoming groups to carbon number 4, and if it's that becomes the major product. And if it's at carbon number 2, it directs all incoming substituents to carbon number 1. So please take note of these two things. And for nitration, something interesting is seen. So whenever you nitrate your naphthalene with its activating group at carbon number 1, it directs the incoming nitro group to carbon number 2 and carbon number 4. So please take note of these two. Okay, so next is to talk about deactivating groups, also known as electron withdrawing groups. These are some examples of these electron withdrawing groups, so please keep note. Now, whenever these deactivating groups are present on the naphthalene ring, they tend to direct further substitution into the other ring. So all other incoming groups are directed to the second ring, preferentially at position number 5 or position number 8. So if there's a deactivating group on the naphthalene ring and there's an incoming nitro group, then it directs it to the second ring. In the second ring, the alpha position is number 5, carbon number 5. So mind you, we can always number alpha and beta even in the first ring or the second ring. And if the incoming group is a halogen, it directs it to the same alpha position. However, if the incoming substituent is the sulfonic acid, it directs it to the alpha or beta position in the second ring. So please keep note of these two. So this is a typical reaction of a deactivating group on naphthalene directing an incoming group, which is a nitro group, to position number 5. And these are other reactions as well. So here we have our naphthalene being substituted with an activating group at carbon number 2 directing an incoming group to carbon number 1. And this is a nitro group directing at carbon number 1, directing the incoming group to the second ring at carbon number 5, or of course to the second ring again at carbon number 8. So please take note of these two. In this case, this becomes the major product, whilst position number incoming group directed to position number 5 on the second ring is